So you're at a client site, you're doing some troubleshooting, and you're working with one of their network diagrams, one of their network maps, and you notice something doesn't seem to be quite right. Maybe you think there's a mistyped number in there, or maybe a port isn't connected to what they think a port's connected to. So what do? You break out Cisco Discovery Protocol if all the devices involved are Cisco devices, of course, and show CDP neighbor. That's the basic use of the command, and it gives you a lot of helpful information: what devices you're connected to, what the local interface is connected to it, what the remote port is that this switch in this particular case is connected to. If you need a little more information, you could always run show CDP neighbor detail. And the big thing with that is that you get IP address information that you don't get with show CDP neighbor. So just a quick refresher on CDP there, but thing is, you run it and then you leave. You fix the problem, everybody's happy, everybody's relieved. They get back to work, you go to lunch, and it's like, hey, I left CDP on. Well, is that a problem? And in today's world, yeah, it probably is, because with CDP, you and I use it for legitimate discovery purposes, and someone else is going to use it to discover things that we don't want them to know. Many networks today make it a best practice to have CDP off at all times. And you can turn it off globally, you can turn it off at the interface level, doesn't matter. And you do remember those commands, right? It never hurts to check those out. CDP run and no CDP run, that's your global command. And on the interface level, it's CDP enable, no CDP enable. So, whether you turn it off at the interface level on all your interfaces or you turn it off globally, turning CDP off is really the way to go. So at a client site, when you turn it on, I always treat it like a debug. And I know I'll tell you that more than once in this lecture, but it's very important stuff. Just as you wouldn't leave a debug running when you leave a client site, you shouldn't let CDP run either. Now, so what's the big deal? The main problem with leaving CDP on is it opens up our networks to what we call recon attacks, and the long form of that is reconnaissance attacks. And just as a soldier in an army, if he or she goes on a recon mission, probably goes out by themselves, looks around a little bit, reports back on what they saw. They didn't go in there to, cause trouble. They went in there to gather data, so in the future, they could cause even more trouble. The entire army's coming then. Because if you pull off what we call a CDP sniffing attack, it's just what it sounds like. You're using a sniffer, you're grabbing all these packets, and you are gathering a wealth of information. Everything from the native VLAN, the IP addresses that are in use, the iOS version in use, all information that can be used in crafting a future attack. Now, there is a more direct usage of CDP for an attack called CDP spoofing. And spoofing, of course, we're going to see that. We've seen it before, we'll see it again, where the attacker is pretending to be something else. And in this case, with CDP spoofing, the attacker sends hundreds or thousands of fake CDP packets to the MAC address 01000C, and the rest of it is all C's. Now, not only can such a flood lead to a highly inaccurate CDP table, the problem with spoofing and then with flooding is that the device receiving these packets, the one that's on the wrong end of the flood, can be basically made inoperable because it's so busy trying to handle all those fake packets that it can't do its job, which is switching or routing. And CDP version 1, which I doubt you bump into in the field, but I see this in every Cisco PDF for the last 15 or 20 years, so I'm going to mention it here. CDP version 1 is especially susceptible to this attack. It's a good thing to know for theory, but I doubt you bump into a lot of CDP version 1 out in the field. Now, the best defense against a CDP spoofing attack, it's very simple. You turn it off when you're not using it, and when you turn it on, turn it back off when you're done, especially visiting a client site. It's good professional courtesy as well. Just like I said, you treat CDP like a debug. It's a great way to get info when you're troubleshooting, but you gotta turn it off when you're done. Now, the same goes for the Link Layer Discovery Protocol, LLDP. And this is the vendor-independent version of CDP. The output is not exactly the same, but it's the same process, really. It's the same kind of information. And LLDP is enabled and disabled globally in a similar manner to CDP, but not so much at the interface level. So you want to watch these. Enabling and disabling LLDP globally, just use LLDP run or no LLDP run. You can enable LLDP to transmit on an interface with LLDP transmit, or to receive on an interface with LLDP receive. And if we're turning it off, what are we going to do? We're going to put the word no in front of those commands. And you can also, there's a show command. And if you see LLDP is not enabled, then you know it's not enabled. You don't have to turn it back off. It's already off. And if it were on, we would, let's go ahead and do that while we're here. And again, it's LLDP run. No options there. You're either running or you're not. I'd like to show you what it looks like. And you'll see just a little information there, global LLDP information, status active, and then some advertising and hold time information. But key there, leave LLDP and CDP the heck off when you're not using them. It really is just that simple. Coming up next, we're going to talk about some CAM table overflow attacks. I'm going to remind you of several different names for CAM tables and MAC addresses. And we'll take a look at what a flooding attack can do to our switch. That's coming up next.